First of all, I would like to thank the organizers for the opportunity to give a talk today. And I will talk about this infrared duality between two unoriented theories. And this is based on our work we published recently with Andrea Antinucci and Professor Fabio Riccioni. So we will first see the setup in which we construct such theories, and we will also see how to represent them with the brain tiling construction and how to perform the oriented thought projection over that. At the end, we will talk about the conformal invariance of such theories. So the context here is the ADS-CFT correspondence, and which in its original formulation states that a stack of n-degree brains with this geometry, with the near horizon geometry, ADS 5 times S5, is holographically dual to a four-dimensional gauge theory, which is highly supersymmetric, and in terms of n equals 1 chiral multiplets, we can write down a superpotential of this four. Now, highly supersymmetric also means highly unrealistic. So we want to reduce supersymmetry here. And in order to do that, we can perform an orbifold involution of the Calabi-Yau cone, whose base is the horizon. And the three weights of the orbifold involution determine the gauge theory itself in the sense that they determine the non-zero entries of the chiral multiplets here, and how the superpotential is projected. For example, by choosing properly these ways, we can obtain an n equals 1 theory or an n equals 2 theory. From now on, we will focus on n equals 1. Now, we can represent these quiver gauge theories with the tools of brain tiling and dimer models. This construction arises in the T-dual configuration, in which we have a stack of the 5 brains wrapped along the torus and NS5 brains wrapping one cycles of the torus itself. So they form a bipartite graph on the torus, and we can read the gauge theory from the fundamental cell. Here is the dictionary in which each phase is a gauge group, each edge is a bifundamental field, and each node is an interaction term. So we can reconstruct the whole three-level superpotential of the theory. Here is our prototypical example. Now, we want to perform an oriented projection over this theory, and this is essentially the two involution of the space-time. So in order to represent the oriented involution and its action on the torus, we look for, we seek the fixed velocity of the involution, and in the case of the torus, we can have 4 fixed points or 2 fixed lines. In both cases, they are physical oriented planes, and depending on the sign, we may have different oriented projection. In this case, here we have an example with 4 fixed points, and whenever a point lie on an edge, then the bifundamental field, the corresponding bifundamental field, can be projected into a symmetric or antisymmetric representation. In the case the fixed point lies on a face, then the gauge group will be orthogonal or symplectic. In case of 4 fixed points, there is also a constraint, which we call the sign rule, which is called the sign rule. In case of fixed lines, the rules are essentially the same. So in this case, the bifundamental field here will be projected into symmetric or antisymmetric representation, depending on the sign we give the oriented plane. Here an explicit example in which we can choose, in order to obtain a consistent theory, we can choose the signs of the fixed points in agreement with the sign rule and the anomaly cancellation conditions. So we may have only these 2 consistent theories. Here there are the relations between the ranks. Now, we are dealing with n equals 1 theory. So we wonder what happens after the unfold projection if these theories may have a conformal point. Now, we know that conformal dimension is related to the R charges. And also we know that whenever there are abelian flavor symmetries, they mix together with the R charges itself, so they cannot be uniquely determined. But we also know that at the conformal point, the R charges are such that they maximize the A charge, this quantity here, which is, roughly speaking, a count of the degrees of freedom. So at the conformal point, these R charges are defined, well defined. We also know that by the theorem, the A charge decreases towards the infrared. Now, what we should expect in the case of the unfold projection? Well, we know that this is a Z2 involution of the space-time, and also it identifies pairs or fields. So we expect that in case there is a conformal point, the A charge of the identical theory of the unoriented theory is half of the A charge of the parent theory. So there are two possible scenarios here. The first one, at leading order, the A charge of the unoriented theory at the conformal point is half of the parent theory, and the oriented projection only yields 1 over n corrections, so subleading corrections. In the second scenario, the conformal invariance is simply broken after the oriented projection, so there is no local maximum at all for the A charge. With this in mind, we studied this theory here, the pseudo del Pezzo 3C, and its oriented projection with 4 fixed points. We may have only 2 inequivalent choices for the signs. The first one we call omega 1, and the conformal point is defined by these relations between the ranks. We see that there are 3 cubic 3-1 flavor symmetries, and we stay in the first scenario, so the A charge is half of the parent theory. But if we choose the signs differently in the projection omega 2, one flavor symmetry is broken, and there is a different relation between the ranks of the gauge groups, and there is a conformal point, but actually it is in the infrared, as we can see, because the A charge is less than half with respect to the parent theory. So we are clearly in front of the third scenario here, in which the oriented projection breaks the conformal point of the parent theory, and a flavor symmetry. The theory flows towards the infrared, where there is a new conformal point there. But that's not all, because if we study the pseudo del Pezzo 3b, which is related to 3c in the sense that the gauge groups and the matter content is the same between the two, but the dimer is different, so the matter fields interact differently, then we see that if we choose the sign of the fixed lines in this with this scheme, then we find a conformal point in the first scenario. And now we compare the result, and we see that a leading order, these are reported a linked order, but actually the R charges are exactly the same between omega 2 and omega. And that also means, since the matter content is the same, that the A charges are the same between the two theories. Also, the consequence is also that trivially tough anomalies and superconformal indices between the two theories match between omega 2 and omega. So our claim here is that the oriented projection for omega 2 for pseudo del Pezzo 3c breaks conformal invariance, but the theory has a new conformal point in the infrared, and it is dual to the oriented projection omega of pseudo del Pezzo 3b. Now we wonder what is the origin of this duality here. A point is that parent theories have different conformal points, so this is clearly related to the oriented projection. We can infer something on the geometry side. From Gobser's formula, we can relate A charges and the volume of the horizon, and since the R charges are changing, the consequence that the volume of the horizon in the case of pseudo Pezzo 3c is changing. we also wonder if S-duality here is involved along the lines of this work. And also, we want to find other examples. And actually, we have an argument to claim that all non-chiral orbifold of suspended pinch point develop the third scenario, but we have not been able to find other examples at this point of the duality. Another line could be also try to investigate what happens in the modularized space of the theory of these theories in the case of the third scenario. So that's all, and thank you for your attention.
Thanks a lot, Salvo. Are there questions, comments? I don't see any. I think I have one, maybe more of curiosity. Can you show the last slide? So when you talk about the possible origin of this duality, can you elaborate more on the third point, the S-duality point, in relation to the work of Iñaki and collaborators? I mean, maybe you refer to orientfold three planes or so, or something?
To orientfold?
Three planes, the various versions of the O3 planes that they discuss in those papers, or?
I'm referring to the works in which they state that there is a duality between the two different orientfold projection of the same theory, and they show that also this is an effect of Monton and Olive duality, a reminiscence of this duality after the orientfold projection. But I have to admit that those papers are kind of high level. I don't understand they very well, but it could be related because actually it's the only duality between unoriented theories we know. The point here is that in their works they show duality, as I said, between two different orientfold projections of the same theory. In the difference is that we have duality between the same or two different orientfold projection of two different theories. So it's slightly different for our case.
Maybe it's a combination of more things and not just that.
It could be. It could be.
Thanks. More questions?